Hi, everyone. We decided to start one of our sessions again. This one is going to be about the different transports we have for these kind of open source or open management protocols. So again, with me, I have Dan and Tomas, and we'll start off with, how do we transport all of these open config and other types of management configuration things to the actual devices themselves. So with that, let me hand it over to Dan.
Oh, thanks, Fred. All right, so we have made it so far through the whole OpenConfig journey at this point. So I think we kind of know how everything is made via OpenConfig. So we talked about the schema, how we created that. We talked about the different tooling you'd use to create the schema. And we kind of talked about like the actual XML, the JSON, the data portion that makes up everything. Now we're going to talk about how we, everyone over here a little bit, how we transport everything, which is going to be different transports related to OpenConfig. So we'll go through today. We'll talk about the different ones, talk about the strengths or weaknesses. I'll give some demos, Tomas will give some demos. I'll cover mostly Netconf, and Tomas will cover mostly the RESTCONF portion. So that being said, here are the OpenConfig transports. So the one we're going to cover today, well, the two that we're going to cover today mainly are going to be Netconf and RESTCONF, and then we're going to have a whole separate video for GNMI, which is gRPC, and that's a really big undertaking because it is very complex and probably deserves a video. But we'll cover Netconf today. We'll cover RESTCONF. So Netconf itself, the transport to actually get this off the switch is SSH, as you can see here. The encoding or the serialization, so all the actual data that you would see, so things that represent your interfaces, your VLANs, the whole configuration, it's an XML. Transport-wise security, it does cover SSH. So typical SSH that you would know and love that you connect to a switch with, it would go over that. This does not support streaming. Anyone who's used the SSH ever can tell you the same thing. But the big thing with Netconf we'll cover are the RPCs. So the RPCs allow you to basically connect from your client device to actually execute something on the switch like it was just on the client device in any typical RPC, which is very neat. The protocol itself is decent with the RPCs. The only real kind of issue most people have with it is that it uses XML and uses SSH as a transport, which is probably a little bit of the issue with it. Can also cover RESTCONF. So RESTCONF transport wise, it's going to be using HTTPS. So in the actual RFC, RESTCONF does require you use TLS. So that is a requirement. It will not work over just plain text HTTP. The data is actually in JSON, so it's a little easier to work with for most people than XML. It obviously does not support streaming. It uses typical methods. So HTTP methods you're used to, get, put, post, patch, delete. And the strengths are it's RESTful. So I mean, realistically, this will work across any programming language. It'll work across, curl. Pretty much most things are just ready to go for RESTCONF. It's just very simplistic, and you don't need any other third-party libraries and so forth. So here's a better picture of what you're doing. So effectively on the Yang tree, which you've shown before, the Yang tree will make up things that are just constants in the switch. I'm sorry, not constant, things that constantly change. So interface statistics, BGP neighbors or routes, basically anything that OpenConfig represents, you need to get that off the box, or you need to actually add data to the box. So the three different transports are Netconf, RESTCONF, and the gRPC clients. But effectively, you're either adding to the Yang tree, or you're taking away and kind of getting information back from the Yang tree. And if anyone also wants to add here, Tomas or Fred, feel free to.
Yeah, I just want to kind of pull it back to the stuff that we were talking about before, right? So you still have your Yang model, you still have your OpenConfig model. You would generate whatever OpenConfig, either XML or JSON that you want, and then you use one of these clients to send it over, or to pull it from the device. That kind of the right way to think about the bigger picture.
Yep. So it's a good big picture view of like kind of how this works. So like you either create the whole JSON or XML schema, data. And the way you actually either push it or grab it from the device is either going to be through one of these three methods. So Netconf, RESTCONF, or gRPC. I think we have just a general configuration of each. Like they're very simplistic. GNMI, which we'll cover next time, but just very easy to configure. Just a couple lines of CLI. Typically, people ZTP with this. So like your Bootstrap config has it, and then you can start communicating with the device. RESTCONF, like I said before, it does require SSL or TLS. So You have at the very bottom the profile called RESTCONF, which you can self-sign assert if you'd like to. And then NetConf is just like very easy. I have port 22 there, but it should be port 830. But very easy to configure these things.
Now, if you set up NetConf for port 22, does that mess with your ability to SSH into the box on port 22 and do your regular CLI stuff?
That's a great question, because I'm a good citizen and always follows the RFCs. No, I don't know. I don't know. That's a good question. We could definitely try that afterward. I don't know what happened.
No, it should be fine. At least I haven't seen issues with it. And sometimes I'm also setting it to 22. In the old days, I know that we were not allowing the default NetConf port in our control plane ACL, but I think starting from 421.3, we've added it or something like that. So it's there by default.
Go. Yeah, definitely need that.
I think one reason maybe you would use 22 is that if you have firewall rules blocking port 830 towards the switches, then you wouldn't need to add that rule on the firewall.
Yeah, no, it totally makes sense for firewall stuff. I'm just curious that I guess something about the session distinguishes between you SSHing in and typing commands versus shooting netconf XML over that same session.
What's the SSH term? It's like you SSH-P or like. I'll come up with that. If you man the SSH page, it'll tell you. There's a term of like, I'll call it like a namespace, but it's like a thing. I can't remember what it's called.
Right. Yeah, I think I know what you're talking about. Okay, I guess we'll see. We can try it out during the demo portion and see what happens.
Yeah, we'll definitely try that. Cool. This is a picture directly from the RFC, so RFC 6241, and it's from 2011. So like, this is not anything new by any means, but this is kind of how this works. So we'll start from like the very bottom and kind of work our way up. So you take an SSH client, and typically what you do is you call one of these RPCs. So RPCs are something like get all the configuration, get all the state and the configuration, edit the configuration RPC, delete the configuration, commit the configuration. They're all different kinds of RPCs, which I'll cover in a little bit. And effectively, once you have that, you'll do things like inside of it, edit the config, delete the config and such. And then the content is going to be your actual configuration, whether you're adding or receiving it back from this. And there are notifications as well too, which is pretty neat. Like, there's a lot of neat stuff in this. It's just the transport just kind of ruins it. And XML isn't really all that fun. But originally, like reading the RFCs and going through a lot of data with this, I think it was a replacement for SNMP. The big thing back then was that instead of doing all the walking of thousands of OIDs, you would SSH. You can kind of give the data back. And they have like a lot of really cool stuff with like filtering. So like, you could literally get the entire configuration, but just filter based off interfaces or filter based off just BGP neighbors and such, without like having to do the standard SNMP bulk data stuff, like, which is not really fun by any means. But yeah, the same thing with this, like the way that GNMI works, they basically have stuff for state, you have stuff for configuration. So configuration would be the actual config on the device, and state would be like interface counters, for example, where config would be interface VLAN or routed and such.
So how does that notification work? Is it I leave the SSH session open, and then something happens, and I'll get a little notification that says config changed or something like that. But it's not necessarily state streaming like we were talking about earlier, where I'm not getting interface counters updated by the second or less than a second. I'm actually just getting kind of more event notifications when I might get a syslog message or something like that typically. Is that the right way to think about it?
It is, yeah. You would have to keep like, I mean, it's almost like having an SSH session open to like a switch and then like doing clear something or other and waiting for, like you said, a syslog message. It's the same thing.
Okay.
I mean, there's a lot of good stuff in here. It's just, you know, SSH needs a bit of a facelift. But yeah. So effectively, here's the way it works. I brought up like the RPCs, the way they work, but effectively you're gonna use a client. So today we have Scraply Go. We also have just regular Scraply. Big difference between Scraply Go and Scraply and regular Scraply is made in Python. Scraply Go is in Golang. And then it's a little, I had to put the word next to it because NCC client, the logo is, if you didn't know better, you would, I don't know what that would be if I didn't know any better. But you take one of these clients or you just standard SSH, you connect to the switch, and effectively the client will then send an RPC. So you could see the get RPC. We just do a get, like you don't really do anything else. You don't have to pass much data inside of it, but you just basically do a get. It is namespaced as well. It's a little hard to explain on that one, but these are namespace, which is going to be XMLNS, and the message ID is a sequence number. And then effectively the switch gives you a response. So it's like severely truncated, but you'll see at the very bottom, like it'll say ACL, and then it might roll through interfaces. Then it might go through network instances and BGP neighbors and all the really good stuff we just couldn't fit on a slide. This is effectively how it works. The client connects, the client runs an RPC, like the RPC was just directly on itself, but realistically it's on a switch, and the switch does what it needs to do, and it sends it back to the client just like a regular response with many other protocols.
Right, now to pull this back to the open config thing. So would open config be what I put, like within that get there, I could specify some open config paths, and then the other side would return open config data?
Correct. Yeah, you would do that sort of thing where you would say like ACL, XMLNS, OpenConfig, Yang ACL, and it would give you all of that. The interesting part about like Netconf is like you can also do like multiple filters. I think people like it for that. So you could do a get like I have, but I don't have an example or anything, but you could filter out based off of like just ACL in one response, and then have another filter on just like interfaces to see like what interfaces are belong to ACL and that sort of thing, which is, I guess it's kind of nice.
Cool.
So here are like the everlasting revolving RPCs. So get literally gets everything. Get config gets only the configuration. Edit config will actually go through and you can edit it. So if you want to edit everything for ACLs and actually do that, and then do what's called a commit, which if you use like our config replace, internally we call that. You can delete portions of the config, you can lock portions of the config, you can unlock it. So those like really, really cool RPCs. The only thing that just kind of that most of them are trying to figure out, like whether this is like kind of screen scraping or not, because like the whole problem is you do these like edit configs or get configs and everything else, and the data that's actually returned to you is typically just a gigantic string of stuff. It's like a gigantic screen scrape, and it's kind of odd, effectively the way it works. And even like Scrapply, in general, if you look at Scrapply or Scrapply Go, they call it screen scraping, and a lot of people call it that as well. But it's just one of those things where the RPCs are good, but the data coming back to you is not structured in any way or that makes sense sometimes.
So that kind of breaks from what I felt like I understood earlier, because I thought we were able to send and receive, let's say, open config models. So is it just that when I get the data back from the switch, it's not, I don't know. I mean, it should be an XML, right? And it should be the model fields and data, or am I missing something?
You'd have to look, like, I'll show you what the model fields look like, but like, it's like a gigantic string, effectively. Like there's no way to like key off of like different things. I'll show you here like an actual, like once we go through how this works. But let me just walk through a demo. Like I have 3 different demos. Like one is just using standard, let's go back here. Standard SSH, which is like kind of funny. So this actually works. So I'm running CEOS on my laptop effectively. But I have both of these in here, but this is like pretty, I mean, I think it's pretty funny, but it kind of shows simplicity of this. Like basically I'm just typing this out to SSH into a CEOS container, which is running on here. And then I'm grabbing that and just putting that in what's called device capabilities. But all I'm doing is a get for the capabilities. So it's going to go through admin, pop it in, and then it kind of looks like this. So you can see here, it's kind of yucky. But I get all the capabilities.
But that's still just XML at the end of the day, right? Like,
right.
If you fed that into an XML parser, it should be able to make sense of that.
Yeah, but where do you get you'd have to get the Yang models and marry them up with every key to Yang and XML at that point. But here, so let me show, like, once you get to the Go portion, we could talk about that. The NCC client, which is the NCC Python client, it's like super easy. You just kind of pop this in, NCC Manager Connect, the host, the username, and the password, what port it's on, and then basically it'll just print it out. So you just do Python 3 capabilities, and we get a quick picture of kind of what that looks like. Capabilities device. All right. So here's kind of what
so what did that just give back to me? So I'm getting a bunch of URLs.
Oh, sorry. What's that?
So what is the output you actually printed here? These are a bunch of URLs like down on the terminal. Yeah, like,
oh, I'm sorry.
What am I looking at?
Let me type it out for less. So when you ask for capabilities,
yeah,
like it will tell you like what stuff is on it, like what
Okay.
Yang models are on the switch. Because like you could see here, let me find a good one here that makes more sense. It's usually like in GNMI, I'll give you like version numbers, but like OpenConfig Yang platform module and the revision. So it'll kind of tell you that usually in GNMI at least, usually a version like 0. something or 1.0 or 2.0. But here it kind of
so this is just telling me what models and stuff are available on this switch for me to access.
Yeah, I think it should have sort of like Yang writable running config. Some of the methods are here, like I'm sorry, some of the RPCs are here too. But basically what it's supposed to tell you is like what the switch can do, what its capabilities are effectively.
Okay. And it's doing that by way of sending me URLs to kind of the spec for that piece of data or that RPC or whatever it's trying to show me.
Correct, yeah. So like when you do like a get, so like when you do a get config, if you wanted that, like the data that's going to come out of like OSPF v2 is going to be like this revision of it. You know?
Okay.
Yeah, I think it's similar to the GNMI capabilities, but it's harder to read or understand because this one points to a URL and
Right. So then
revision.
you have to go click. Yeah. So you have to go click on this and then see what that actually does.
Yeah, this is way harder because like GNMI, like you said, like you're saying, like usually when you run capabilities, it gives you like version 1.1, version 2.5 or something. Like this is kind of bizarre, to be honest. All right. So here's everything with the Golang portion of it, like well, the Scrapply is what it's called. And Scrapply stands for, I think literally screen scraping. But I have the XML formatter, which just kind of makes it look a little pretty. And then basically have Scrapply, base driver, and Netconf. So effectively right here, like we just open up a new Netconf driver, which makes a connection to that same device, admin password. And then we have this little method called getConfig, which is probably just literally a get. And then in the actual data, just asking for running, which is the running configuration. And once I have that, I just pipe that into the return, which like I'm saying is this thing, is a string. So, and after I get that, actually, yeah, good.
Scrapply Go is taking your command, which or has a method called getConfig, and it'll take that and then turn that into the XML call that you need to make.
Correct. Yeah, like it's literally doing. Where are we at here? This is get. Yeah, so it's literally doing this.
Okay, but you didn't have to write the XML in this case. Scrapply Go took kind of an arbitrary command or a method here and then converted that to XML for you.
Correct. Yeah. Yeah. And you just got to type the word run. Like, so it has the word running inside here. I don't have to work with nothing, but basically like under get, it would be like whatever bracket running / bracket running. Like within here.
Got it.
But then all the data, like I said, like it comes back to you in like just a giant string. So you'd have to have a way effectively through Netconf to have like every single one of the models kind of come back and parse through that Gigantor string and mix and match it. That's kind of the issue. So we'll run it and we'll kind of take a look at the file. Looks a little prettier because obviously it's an XML on VS Code, but you kind of get everything for the running configuration and so forth. So yeah.
Right, but in this case, like this doesn't line up, or does it line? How does this line up with the OpenConfig model?
What do you mean?
Like, are these fields, leaf nodes in an OpenConfig?
No, I think this will very different from like somewhat, but I don't think a lot of this will match up with like what you would typically see with like all the it would be very hard is what I'm trying to say.
Yeah, but the data model is the same, so it's based on Yang as well.
Right.
So it's a Yang model, but is it an open? I mean, maybe I'm misunderstanding, but is it an OpenConfig Yang model, or is it some other Yang model that's been specified?
I think it's both OpenConfig and
EOS.
IETF, no?
Yeah, you have like you're gonna have all kinds of stuff. Like you'll have like EOS models on here, like experimental EOS models, and you also have like OpenConfig models.
Okay.
So like BFD augment, like so BFD. And I don't know if we have any IET, like it's effectively the same as like GNMI doing a get for slash effectively. But yeah, you have some IETF stuff, a whole bunch of stuff in here.
So it's a mishmash of different Yang models.
Correct. Yeah, it's the same thing as doing a get for like slash effectively.
Okay.
So that was Netconf. It was a fun time. So I'll turn it over to Moss here to do most of the RESTCONF portion here.
Sure, let me share my screen. Let me put the slides over. All right, so RESTCONF. RESTCONF first appeared, I think, a few years ago, and the RFC is 8040, which was written in 2017, so not that long ago. It uses HTTP as the HTTP methods to provide the CRUD operations, so create, read, update, delete, as Dan mentioned before as well. And just wanted to put this table here just to have a comparison between RESTCONF and NetConf, and what are the methods in both of them. So on the RESTCONF side, because it's HTTP, we just use the usual HTTP methods like get, which is for retrieving data for a resource. On the NetConf side, it was get and get config. Then we have post, which is for creating a data resource and is generally used for the create operation, which was the edit config on the NetConf side, specifically the create operation. And then we have put, which is the create or replace, which can create or replace a target data resource, and is used for replacing and replacing and updating data, which is again edit config on NetConf side, and the create and replace operations. And then we have the patch method, which is used for patching basically, but it's very similar to post. And in EOS, actually, post and patch today are treated as a merge and create operation. And then we have the delete, which deletes a target resource, and which on the NetConf side is also edit config. On the RESTCONF side, the transport is HTTPS, so it's much easier to use than NetConf, I would say. Especially if you like using curl or postman or Python requests, you don't have to learn anything additionally. You can just use your existing knowledge and query data from the switches or modify the configuration on the switches. And the data can be encoded either with XML or JSON, although I highly doubt it that folks use XML with RESTCONF. And with netconf, it's RPC messages, which are XML only.
So,
And
so the difference here between, let's say, a put and the patch post is the put is like doing a config replace on the box, and a post or a patch would be like just adding a line of configuration, but not actually doing a full-on config replace.
yeah, exactly. And I have a few examples I can show quickly, which would be on this slide as well. So basically here, let me just, can you guys see this, or should
Maybe a little bigger would be nice.
Yeah, let me just do that.
I'm the senior citizen here.
Is this better?
Yeah, that's better.
Awesome. Let me clear this. So in this case, I'm just getting the system config on this device, which returns me the hostname and the message of the day banner, which is test in this case. So if I want to patch things, let's say I want to change the banner or add the banner. If the banner would have not been there, it would have just created it. Test RESTCONF webinar. And if I do a get again, we can see that the banner has been updated. However, if I use the put method, then that will remove my host name. So if I do a get again, but we could see it also in the result what happens, because it actually does it returns the result as a get, and we can see that my host name was removed. And if I hit enter a few times, then I can see it's localhost, which is the default host name. So that's kind of the difference between put and patch and post.
So wait, let me dissect this a little bit.
Sure.
Actually, can you make the right pane a little bigger? You made the left pane bigger, but the right pane still.
Oh, I thought that it made both of them bigger.
Yeah, I think it only made that's a little better. Okay. Anyway, so the first thing is like, so when you're doing the get call, right?
Yeah.
You're doing it to /data/system/config. So you're using, I mean, this is typical REST, right? You're using the URL fields to define where in the data model you're doing manipulations.
Yeah, exactly. And this is very, very similar to GNMI and what we demoed before, which is why it's much easier to use than NetConf.
Now, if you do a get from, let's say, a higher level, let's say you just did it RESTConf/data/system, would that give you like even more data? Like, is that just going to give you everything from that route, or no? It doesn't.
It depends if the data exists there or not.
Okay.
In this case, it doesn't seem to be there. So
the one thing that's cool is like the keys. So like if those work too, right? Like the Yankees, like if you interface/interfaces, like name equal, like that's just pretty cool.
But yeah, in general, it should return that interface.
Okay.
Let me check what was the interfaces path. Interfaces.
Yeah, that's it.
Interfaces. Interface. Maybe some of them.
Too many interfaces, I think.
Yeah.
Interfaces,
maybe.
:interfaces.
No, it should have been like that. Let me just.
Oh, then you need a hyphen. I think you used a colon instead of a hyphen. Open config -interfaces.
Oh, was it like that? Oh yeah. Okay. Yeah, you're right. Yeah, let me just paste this.
Yeah, you got a lot going on here. A lot of windows.
Sorry.
Okay.
Okay, right. And now let's start deleting stuff.
There you go. Okay, cool.
Okay.
Right. So yeah, if you back it up to there. Oh, never mind.
It doesn't seem to like it.
Okay.
But it should, in theory, return. Okay, this one.
There you go. Okay.
So I guess it depends how far back you go.
Okay. So now that's giving me that. It's giving it to me for all the interfaces.
Yeah,
versus
exactly.
that other time you did it, it just gave it to me for one interface. Got it.
Yeah.
Cool. And then, all right. So the first thing, that's kind of the first thing I was noticing. So you're using the path on the URL to define where in the data model you're either getting or putting or posting or whatever. So then when you scroll back up a little bit more to your example, you did the difference between, say, the put and the patch, or the put and the patch.
Yeah, this was the patch and this was the put.
Right. So you went to the exact same path, and because system/config contains like multiple fields, when you did the patch, it only updated the field that you tweaked, right? It only updated the MOTD banner, versus when you did the put, it wiped out everything at that path and only stuck in MOT banner. So kind of that config replace kind of thing.
Yeah, exactly.
Okay, got it. So yeah, so if you could mess yourself up if you started doing puts at too high, too far back on the tree or too far back on the path, because you could wipe out a lot of stuff that you didn't intend to.
Yeah, if things are tied together, then you have to be very careful. So I guess it depends on what you want to do. Maybe sometimes you want to do a replace, or sometimes you just want to add or append to the config or merge it or just update that part.
Now, is there a concept? Because I feel like on the RESTConf, or sorry, the NetConf, wasn't there like a commit phase? Like you push stuff in and then you could do a config commit on it. Was that part of the NetConf functionality? Or maybe
okay, I know what you're saying, but I don't think I've seen that in RESTConf.
Right, because here it's just you just do it and it's immediately changed, right? There's no config session kind of thing here.
Yeah, no, I don't think so. I have to check if there's.
But there is in NetConf or no? Or
there is in NetConf. Yeah, there
in
is
NetConf. Yeah.
You have these data containers, or containers, not to be confused with actual containers, but you have those, which are like pretty cool. But yeah, you could basically do what you're talking about, which is like the same as a configuration session for us. I think RESTConf is good for like external tooling to get stuff. I think NetConf is good if like you actually want to configure stuff.
Yeah, that's kind of interesting. Yeah, because it gives you that extra level of what a config session gives you, right? It gives you the ability to do a bunch of manipulations and then hit the commit button, versus as soon as I put it out there. I mean, again, back to that example, if I hit something at a path that was a little too broad, I could really mess myself up with the puts.
Yep.
Yeah, which is why it's always recommended to test these things in the lab first, not in production.
Right.
Yeah, and so I also have some Python examples, which are also available on our website, which I'll show in a moment. But basically, you can just use the request library to request for to run your get calls or your post or put or delete or whichever you want. And for instance, if I just want to get the state of this interface, then just simply add the URL here and then do a request get on that URL, and it should return you the interface state. So like that. And I also wanted to show this delete operation, which, let's see if I have this interface. So in this one, I'm just trying to delete loopback 101. And it's the same, the path doesn't change if you want to get this path and you want to delete it. It's just the same. The URL is the same. The only thing that changes is the method. So you would use request.delete. And the same you can do with curl as well. So when you do that, deleting, and then it's gone.
Cool.
And the same, I guess you can do it in Postman or anything that supports, RESTConf or REST APIs or HTTPS based APIs.
Now, are there any tools that will take, I'm kind of still getting stuck on, that I'll take the OpenConfig models and then convert it into these URLs for you, or convert it into the things that you're getting back from these URLs so you can manipulate it easier? Or is it seems kind of manual?
I think you could use Pyang, although I haven't tested it yet, because the JSON should be very similar, if not the same, as with GNMI.
Right. Yeah,
So,
that's exactly. That would be, exactly like what I'm going for. Like, could you use Pyang at least for when you get the data back, when you get that JSON back?
I would say you can use it, and YGOT as well. But again, I
Right.
haven't tested, but
Okay.
But to me, the key value pairs look exactly the same. So,
Okay.
and the path is also very similar, except, in GNMI, you have the square brackets and you're
Right.
using that to filter
Yeah.
on sublifes.
Do a get and change config to state and see if you get stuff, just out of curiosity, or do a get method.
Sorry. Yeah.
Okay.
Yeah, it doesn't.
Well, you blew away 101, right? Loop back.
Oh, yeah.
do Ethernet one. Do you like Ethernet one?
No, state is there for sure, because the Python script that I used had the state. Yeah, and
so
this one, this one looks pretty similar to GNMI, I get to me.
Yeah, it's gonna be the same. Like you'll get it should be the same model effectively. Like the way it has state or config, it should really show up the same.
Okay, so that's kind of nice. I mean, at least if I'm using this, I can still leverage Pyang or YGOT or whatever to be able to serialize, deserialize models. I might have to monkey around with how I get the actual paths set up right for the URLs, but the actual data models are the same whether I'm using, we're going to put this out there, whether you're using GNMI, whether you're using RESTConf, NetConf, kind of back to the nice thing about OpenConfig is it specifies this common data model across the board.
Yeah. And kind of the last thing I wanted to show, which we showed last time as well, but just wanted to highlight it again, is that in the latest CloudVision, you can also use RESTConf to get OpenConfig data out of the switches from CloudVision. So in that case, and actually you can use the brackets and the same path notation as with GNMI. So I guess it eases your job a lot if you're using RESTConf to get data, because you can use the same paths. And in this case as well, like this 12.1.174 is my CloudVision instance, and I'm trying to get the counters for Ethernet 2 on this device. And in case of CloudVision, you would have to add some query parameters like the Arista target, which is the serial number of the device, and the Arista origin, which can be OpenConfig or Arista or FMP, I think. But you would have to specify OpenConfig, otherwise it would not look at switch data, it would look at CloudVision data, like generated by the server itself, not by the switches. And you can do multiple gets and see how the states are changing, like this in octets is incrementing here. And again, what was cool about CloudVision is that you can actually use the telemetry browser as a path explorer for OpenConfig data. So you could also check it here and look at the counters and check if they are incrementing or not. So maybe
it's really cool, because then if you don't want to necessarily open up the RESTConf to everybody to be able to hit, you can just only open up access to CloudVision from a security standpoint, right? And now I can just proxy all my requests through CloudVision rather than having to have every single switch exposed.
Yeah, exactly. And that's one other thing I wanted to mention with RESTConf. We still don't allow the RESTConf port by default. So you would have to add it to your control plane ACL. And this is also mentioned in on our website. So it would be, by default, it's port 6020, but obviously you can just use whichever port you want. And add that to your control plane ACL.
You guys mentioned that you also need the certs or a cert of some sort.
Yes, so in case
this
of
work?
RESTConf, because we use TLS, you have to have a certificate. So you can either generate a self-signed one, or you can, add your signed certs to the switch. But if you just want to generate a self-signed one and start testing it, it's pretty easy. You can just use the security PKI certificate generate command, which we have here, and then just create an SSL profile under management security and mention the certificate and the key, and then use that profile under management API RESTConf.
But another nice thing, if you're doing it through CloudVision would already have a cert, right? And more likely you would have that cert kind of installed everywhere. So you don't have to go through all of this necessarily on every box and, a bunch of random self-signed cert, or whether you generate certs for every switch or whatever it is.
Yeah, exactly. Like you don't even need to enable RESTConf on the switches if you are using RESTConf on CloudVision. You just need to have GNMI enabled. And by the way, in the backend, it's using the same agent. So it's using the Okta or OpenConfig agent when you enable management API RESTConf. So don't go looking for var log agents RESTConf file, because it won't be there. It will be in the OpenConfig or Okta file.
Cool. I think this was great. I think, we want to save GNMI, or I should say gRPC for another day, because that's a whole can of worms. But this is really great intro to NetConf and RESTConf, and some really nice examples. Any kind of parting thoughts? Actually, one thing, we mentioned, it seems like NetConf might be nicer for config changes. RESTConf is better for grabbing data, but any other broad thoughts on why you would use one over the other, or advantages of one to the other?
I mean, you kind of hit it there. I mean, like Netconf is good for all the RPCs, like the commits and adding and changing configuration, committing configuration and such. I think RESTConf is good if you have external tolling systems that say, how many of my devices have so-and-so VLANs, or how many of my devices have XYZ feature. It's just very easy, like even Tomas brought up, was just in any code, any language, or anything really, just external tolling to go out and reach the device and check the status of something. I think that's really where both are used predominantly.
Cool.
Yeah, absolutely.
Well, I think this is great. We will follow this up in hopefully a few weeks with a deeper dive just on gRPC. And thanks for your time. And yeah.
Thank you.
Well, thanks everyone.
Okay, cool. Thanks.